Okay, so now we have permutations or combinations. We know how to do those because we learned that yesterday, but this is in words. Okay, so let's see. There's a group of 25 people that are going to run a race. The top 3 runners earn gold, silver, and bronze. First of all, let me ask you, does the order matter? Well, yeah, it does, right? Because the first one receives gold, the second one receives silver, the third one receives bronze. Okay, order does matter. So that means we're going to do permutation. Okay, let me write this as P for permutation. Order does matter. If you just said the top 3 get medals, right? The medals are the same thing, then order does not matter. But here, because the medals are different, order does matter. So this is permutation. We're going to do 25 people, permutation 3. Because we're going to choose the top 3 runners. Okay, so let's do this. Remember permutation, it was 25 factorial over 22 factorial. And the 22, because I went 25 minus 3, remember? Remember we did that yesterday. So, okay. Now 25 factorial. Ooh, I'm definitely not going to go all the way to 1. I see at the bottom there's a 22 factorial, so I'm definitely going to stop at 22. Remember, 25 factorial is 25 times 24, all the way to 1, but I'm not going to go all the way to 1, times 23 times 22 factorial. Remember, my 22 factorial basically go 22 times 21 times 20, all the way to 1. I stop at 22 factorial because I have a 22 factorial at the bottom, so might as well just cancel my groups altogether. Now 25 times 24 times 23. My answer in this case is 13,800. Okay, remember, if order does matter, permutation. If order does not matter, combination. Take a look at question number 12. The student body of 70 students want to elect a president and a vice president. Does order matter or not? Yeah, because the first one's a president, the second one's a vice president. So because it does matter, we're doing permutation. There's 70 students, and we're going to choose 2, right? President and vice president. So we're going to go 70 factorial over 68 factorial. Okay, that's not bad. Now 70 factorial, I'm definitely not going to do all the way to 1, right? There's a 68 factorial at the bottom. You guys see how there's a 68 factorial at the bottom? So I'll make sure I stop at 68. So, okay, 70 factorial is 70 times 69 times 68 factorial. The factorials cancel out, so I just go 70 times 69, and my answer is 4,830. If order matters, we do permutation. Let's take a look at number 13. 3 out of 9 students will ride in a car instead of a van. Does order matter? No, it's just the 3, right? It doesn't matter who gets picked first or second or third. So I'm going to do combination in here. From the 9 students, I'm going to choose 3. Okay, so combination. It has to do 9 factorial over 6 factorial. Remember, 9 minus 3, 6. So that's where I got the 6. However, this thing includes a 3 factorial. Okay. Which one's the biggest factorial at the bottom? There's 2 factorials. Which one's the biggest? 6 factorial. Okay. I'll put that one here. So my top 9 factorials, basically 9 all the way to 1, but I will stop at 6 factorial. So that gives me 9 times 8 times 7 times 6 factorial, because I have the 6 factorial, so they cancel out. Good. At the bottom, I still have 3 times 2 times 1. Multiply the top, multiply the bottom, then divide. Okay, so the top, what's 9 times 8 times 7? 504. At the bottom, what's 3 times 2 times 1? 6. Lastly, what's 504 divided by 6? And I'm going to get 84. Okay, let's take a look at number 14. A team of 10 basketball players needs to choose 2 players to refill the water cooler. Does order matter? Does it matter who gets picked first and who gets picked second? No, because order does not matter. We're going to do combination. From the 10 people, we're going to choose 2. Okay, so this is 10 factorial over 8 factorial. Remember the 8 because I went 10 minus 2. Because it's a combination, this one includes a 2 factorial still. Okay, from the factorials at the bottom, which one's biggest? Well, 8. Okay. So my 10 factorial on the top, I will stop at 8. So 10 factorial, remember, is 10 times 9 times 8 factorial. I stop at the 8 because there's another 8. They cancel out. At the bottom, I still have 2 times 1. So on the top, 10 times 9, I got 90. At the bottom, 2 times 1 is 2. 90 divided by 2 is 45. So if they have a group of 10 people, and I'm going to choose any 2 of them, I'm just going to randomly choose 2, there's 45 possibilities that I can do that.